Now, the next thing to do is get into the notation, like how you describe functions, how you write them. So we're going to do a comparison of how we're used to it from like the linear discussion, chapters 1 and 2, and how we're going to start talking about it going forward. Back in those chapters, when I gave you guys a y equals an x plus b equation, if I said x is negative 3, what is y? All you would have done was plugged in. When we use function notation, we actually just talked about a little bit different. We replace the y with a symbol f of x. F of x is a symbol for a function. And that x value is the same x value that sits over here. So if I say, what is the f of negative 3, what I'm saying is evaluate the function or plug in negative 3. And you get the same answer. So now compare the two ways of going. Y equals 2x plus 3, I tell you x, you plug in x, you give me y. F of x equals 2x plus 3, I say, what is the f of negative 3? What is the function's value when x is negative 3? I still plug in negative 3. No matter which way you look at this, it's a plug-in idea. So we just got to kind of get used to the function notation. Get used to seeing that and plug it in. Once you guys get used to it, no big deal. So a little bit of practice of plugging in. So we're giving you a couple functions up top. Let's evaluate the f of. F of means f of x. You place the x in the equation with whatever you're asked to evaluate. So f of 8, plug in 8. So all I did was replace, substitution, right? F of x, okay, shove that x into your equation, work it out. 21/5. F of negative 7, okay. What I'm doing here is trying to model this. So parentheses is where my x's are. And then I'm going to plug in negative 7. So once you kind of just get used to, I guess, the symbolism part of it, it's very easy. It's a plug-in idea. Replace the x with whatever is sitting in that set of parentheses. F of means evaluate for that number. So again, a little bit more practice here. If I'm doing x squared minus 4 and I want the f of 8, then I guess I should plug in 8 for x. I should plug in negative 7 for x. You can evaluate with whatever. Okay, here's a letter. Plug in b. I could say, what's the f of, say, Trevor, and I'm going to plug Trevor in there, Trevor squared. So, whatever. It's a plug-in concept. Okay. And then I would go 64 minus 4. So 60, 49 minus 4, 45. B squared minus 4, not get a number. One thing to watch out, guys, when you're doing squared, don't forget what squaring means, especially here. Squaring means to multiply something by itself. So negative 7 times negative 7, positive 49. One of the errors that I saw, this was back in, it was one test question, I think chapter 2 maybe, is people treating it like this and then going, and it's a plug-in idea, so square whatever that number is. A negative number squared is a positive number. Okay, so there's evaluate. And again, like I said, I think it's pretty easy. It's a plug-in concept. F of what? Well, plug in whatever you're asked to plug in. So f of 8, f of negative 7, f of b, f of whatever. Okay, let's try some other stuff. So that same concept taken to a sort of a visual is, can you evaluate from a graph? So evaluate by plugging into an actual function. Evaluate from looking at a graph. And when you do the graph, now we can use f, by the way, which we do quite a bit for function, but we can use g, we can use h, whatever. So if you change the letter to g, that doesn't change what you do. What is the g of 1? Well, the g of 1 is saying my x value is 1. So what I should do is go to an x value of 1. Because, of course, this is the x-axis. And then what I want to do is run up to my graph and plot a point and say, all right, 1 comma what? So remember, in that set of parentheses, g of 1 is an x. And really we're asking you what's the y value that corresponds to it. So that y value that corresponds to it would be 3. So the g of 1 for my graph is 3. Now go to g of negative 2. Okay, well, this is my x value, and I go to negative 2 on the x-axis, which is here. And I say, all right, on the graph, because now I'm actually on the graph, what is the coordinate? It's 0. So to do evaluating graphically is like just find the coordinate. You're basically given half. You know, so when it says g of 1, it's like saying 1 comma question mark. When it says g of -2, -2 comma question mark. The question mark is, you know, what's the other half of the coordinate? So go to your graph and find it. What's the other half of the coordinate? When you go to questions C and D, it actually works in reverse. So in reverse, it's, I'll give you the y, you tell me the x. Find x when g of x is 0. Now, in this case, this is like saying y right here. So now I do this problem the opposite way. 0. I was looking ahead of the next problem, sorry about that. What is x? That's that coordinate right there. That's an x of -2. When y is 2, which is now this coordinate up here, blank, fill in the blank, right? So there was a y of 0, x is -2. Here's a y of -2, x is 0. So treat it as a coordinate and you'll be in good shape there. Now, I switch away from the graphical idea to say, what if I give you a function and do sort of a similar problem? When f of x is equal to 3x plus 5, find x when f of x is 14. We have done this kind of stuff without the f of x notation. You guys have done it plenty of times. So what I want to do then is sub in 14 and just solve for it. So replace your f of x with what it says f of x is, solve, and you got it. So, you know, again, you kind of start getting used to function notation. It isn't that big a deal. It's like, just be clear on what is in that parentheses. G of -2, g of 1, those are x values. If you present it with the C and D questions, then those are y values. Finish off the other half of the coordinate. Okay, last little bit of this, and then we'll wrap it up, is doing combining functions. Combining functions is really just doing operational stuff, so add, subtract, multiply, divide. And so you'll be given two functions and asked to just do whatever it says. I think the first part of this, real simple. F plus g means you literally will add f and g together. So we'll add those two together. X minus 4 plus 2x plus 3. And what you're doing is creating a new function. So if I combine like terms, this is 3x minus 1. So we call that the addition function, the addition of the two. When you go to do the problem, I'm going to slide it over here for a sec to this one. It's the f plus g of 2. Now use the new addition function. So you'd be plugging into this one. So we've already figured out that the addition function, combine the two, produces a new one. Now use a new one to evaluate. So 6 minus 1 is 5. And that's really kind of what we're doing in this area, just practicing doing some basic operational stuff. So I'll do the f minus g. All right, so take the f function, subtract the g function. Now be careful here that you distribute the negative in as you go. So x minus 2x would be negative x, and 4 minus 3 would be negative 7. So now I've created the new subtraction function, and now I'm going to use it. So I'm going to plug in 3 into the subtraction function, and I would go negative blank minus 7, plug in the 3, negative 10. So the idea here is you're not plugged into either one of the original two, you're creating a new version. So we got addition, a new function. We got subtraction, a new function. Multiplication, division, we can just keep creating new functions. So we do the multiplication of the two, just do what it says. Take the two of them and multiply them together. Now that becomes a FOIL problem. I think when you go to do this and you FOIL, so 2x squared, that's my first term, outside is positive 3x, inside is negative 8x, so negative 5x, and then last term, negative 12. If I was you guys and I'm doing the evaluating part over here, I would probably not use this one. I think I would use this one. Because the factored version to me is easier to plug into. So in those spots where I left the space would go my negative 1. You can plug negative 1 into this one too, but I think you're easier just to use that kind of before you multiply it, before you FOIL, will just be an easier way to go. And so, because look at the way the work is going to be simple here. That's going to be negative 2 plus 3, which is 1. So I'm getting, if you're going and plugging negative 1 into here, here, and then clean it all up, that's a little bit more work. So addition, subtraction, multiplication, create new versions of the function, now do division. So f divided by g. Now when you guys do f divided by g, this is probably the easiest one. You literally just put f over g and stop. That's it. That is the f divided by g function. And then I go over here and I use it. So when I go to use it, just replace your x's with whatever you're trying to evaluate. In those spots where I've got blanks, I go on -2, because those are where my x's are. Remember, the notation is the f of g, f divided by g, we say the word of, but the of is what are you plugging in? So -6 over, that's -1, so you're getting 6. So today I think is more about you guys getting used to the symbolism than the work. The work is not a big deal. The work is stuff we've already done. You guys can plug numbers in and crunch numbers. You can do FOIL. You can add like terms, algebra stuff you got. It's just getting used to the symbolism. If you get used to that, then you should be good to go. Okay, that's going to do it for today's notes.